Matching pennies. There is player A and player B, and each player have penny. They must simultaneously choose to show their heads or tails. The rule of the game of as follows, that if both pennies is matched, like both head or both tail, then players A win and tails takes player B's penny. If both pennies do not match, then that means one head and other is tail, then player B win and takes player A's penny. So the payoff matrix is for player A has two strategy, head and tail, and player B also has two strategy, head and tail. Payoffs are given: 1 for head head, 1 minus 1, head tail minus 1 1, tail head minus 1 1. And for tail tail 1 minus 1. There is no payoff strategy in Nash equilibrium, because if we check that if player A choose head, the payoff is 1 minus 1, but in case of player B will choose tail, because if player B choose H, then payoff is minus 1, but if choose tail, then payoff is 1. So there is no payoff strategy in Nash equilibrium. But head head, if there is same pennies like head head, then player A will win, and if there is tail tail, then also player A will win because the pair is 1. But if head tail and tail head payoff, for head tail and tail head payoff, player B win, uh, because player B win because that the payoff for B is 1. That is why there is no pure strategy Nash equilibrium. We find the mixed strategy Nash equilibrium in this case, and this already explained. So here the probability of expected payoff of a head, it's P, and for tail 1 minus P. This is for player A. For player B, the payoff for head is Q, and payoff for the probability it's is 1 minus Q for tail. Here we find out the expected payoff and equalize both the payoff, expected payoff of head and expected payoff of tail for player A, and for player B we also equalize the expected payoff of head and expected payoff of B for second player, that means player B. If this is q into 1 plus 1 minus q into minus 1, that means q here multiply probability q into pay of 1 and 1 minus q probability into 1 minus 1 and is equal to 2q minus 1 expected value mm, of player A uh, of choosing strategy A, choosing strategy H, and expected value of TA, that means expected value of player A of choosing strategy tail, that is equal to 1 minus 2q, equalize them and getting q is equal to 0.5. And for player B, expected value of player B of choosing a strategy, that is 1 minus 2p, and expected value of player B of choosing tail strategy is equal to 2p minus, that is 2p minus 1, equalize them and getting the value p is equal to 0.5. So the equilibrium condition of the mixed strategy Nash equilibrium is p value half, 1 minus p value is half, q value is half, and 1 minus q value is half.